All right, so what we're gonna do here is we're taking apart the solar setup and then gonna move that over to the other house. We're gonna make this a little more extensive video because it's a little more complicated than carpentry, and a lot of people would like to know about it. So, well, I have my banks in an array, and mine aren't one array like a lot of people, because when you do that, you're relying solely on your battery bank after the sun moves out of position. So I've got mine set up to catch it in a few different positions. And all we have is I just built some frames and put Unispread up. And then I got some clamps here. And these clamps go over top, because I used to have, right here you can see I used to have Timmermans. And this is called a Timmerman. And this just makes it so a hole like this has a bolt through it. But then one year, we had a real wicked windstorm and it ripped off a few of these panels. So that switched up from doing a Timmerman to clamps that go over the top. Holds quite a bit better. So then what we got here is these are just clips. And these are usually tough to get apart. I'm probably gonna take some dielectric grease and dielectric grease them so I don't get corrosion on the metal inside. And then you can see there's a little O-ring here to kind of make it to waterproof the whole deal. These don't come apart very well most of the time. So hand me the, there we are, alignments. So as you can see here, all we're going to do is undo these clips, and you can see that these are 38.7 volt, but it really only pulls closer to 30, and that's the maximum that it's going to pull. So mine, I have to tie, my system runs off 48 volts, so that means whatever I send in has to be higher than that. So two of these together would be like 60 volts, and that's fine. But the problem is that's when sun is on max position with it, and it is just smashing it, which isn't happening most of the day. So I tie three of them together, and I have a little Y configuration connector that ties three of these together, and then that's sending what would be a maximum of 90 volts, but it's not really 90. 70 is about the highest I see it. It averages right between 55 and 60. It sends that amount of volts to a combiner, and then the combiner puts all these together into one and sends them to my solar controllers. So 57, 55 volts is getting to the solar controllers. My system's a 48 volt system. The solar controller then drops it down to 48 volts. The reason you always want that to be higher is if it dips below, then that starts messing up your electrical items. So you always want it to be above, and then it puts it down below and you get a nice even stream. So we'll pick up here when I go to do the combiner, and where the combiner happens is the voltages will stay the same at the combiner, but then it'll put it all into one wire, and that one wire will have a much higher amperage than the individual wires. So we'll pick up there.